Okay, so this is Elise Jackson.
And Hani Abu Hamaidan.
And our project was the Give Me One Reason to Stay Here, which was a siting analysis of 10 individual cities within the United States. So we chose as our top 10 cities this list by U.S. News in 2016, which was Denver, Austin, Fayetteville, Raleigh, Colorado Springs, Boise, Idaho, Seattle, Washington, D.C., San Francisco, and Sacramento. And our goal was to find where inside each city we wanted to live. So a scenario would be you buy a house in one of these cities and you happen to be next to one of the freeways, so you end up with a lot of loud noises, which means that you can't sleep very well. So one night, it's midnight, you want some ice cream because you can't fall asleep. You go to get your ice cream, go to the fridge, and there is no more ice cream. And unfortunately for you, the closest Walmart is 20 minutes away, and you're way too tired to make this drive. Or your mother-in-law comes to visit, and the airport is an hour away, which means an hour of awkward conversation in the car. So you finally decide that where you've lived in this dream city is not such a dream, and you decide to move. So you need to figure out where you want to live in a new city, or in the same city. So you need to live close to a freeway, but not too close, so that you can sleep at night, close to the airport, a reasonable distance to the nearest Walmart, close to the emergency room. So then your life is great, and everything is wonderful because of where you live. So the design parameters that we decided for this project were freeways, airports, hospitals, and Walmart. So we wanted to be within these specific distances, but no closer than a specific distance. So this led to a model builder model.
So now I'm going to talk about the ARC map model that we created. So we created a template for the map of the output of each city, and the input that we used in this project for the 10 different cities are the airports shapefile, the city boundaries shapefile, the freeways shapefile, the hospitals shapefile, and the Walmart shapefile. The airports shapefile and the hospital shapefiles are nationwide, while the Walmarts and the freeways ones are state ones, right? And the city bound shapefile is for each city. So if we drag these into the map here and zoom into the layer, so we can see the city bounds of Austin City, and these are the freeways, these are the airports in that area, the hospitals, and the Walmarts. So this is the structure of the template that we're going to use as an output. It has the legend, it has the names, the north arrow, the title, and the page number. So starting with the model builder, these are the inputs that we used for this model. These are the city bound shapefiles with the airport shapefiles, the city bound shapefiles with the Walmarts, the hospitals, and the freeways. Then we clipped these state shapefiles or nationwide shapefiles into the city bounds of each city to get the clipped file of airports, hospitals, Walmarts, and freeways. Then we buffered these shapefiles to specific distances. We transferred them into rasters and added them up to get the final output, which is the best places to live at in a city. This is a picture of the map that we're going to get as an output for each of the 10 cities. And as we can see here, there is the base map of each city. The legend shows the raster for the best places to live, where the dark color is the worst place to live and the light color where the best place to live. The title here and the page are the text elements. They get updated whenever we create the PDF file. And when the user runs this script, it prompts out two inputs, which is the master folder, which is the cities folder that we're going to use for the 10 cities, and the geodatabase. Now moving to the code that we used and the script that we created to do the function of finding the best places to live in a city. So the shape files were downloaded, as I said before. So we imported the modules that we're going to use. These are the general parameters that the user inputs, which is the master folder and the geodatabase. The environmental settings are imported to reduce the chance of getting errors when running the script. So we created different functions for this script, and the first function is the geoprocessing function, and this is the main function that we're going to use here. That includes clipping, buffering, converting the polygons to rasters, and for all the different shapefiles, and adding these rasters together to get the final raster that shows the best places to live in. So the first step that we're using here is defining the local variables for each function: the freeway clip, the Walmart clip, the freeway buffer, the Walmart buffer. And we also so starting with the first step, which is clipping the shapefiles. So we use the arcpy.clip analysis to clip the shapefiles. So we have the input here, and this is the how we're gonna clip the freeway, and this is the output. So this function clips the nationwide shapefile according to the city bound shapefile, and the same process was done to all other variables, including the airports, including the hospitals, and the Walmarts. After that, the clip freeway variable was then buffered to different distances, as Elise said before in the PowerPoint slides, and these are the distances used. And the function used here is arcpy.multiple ring buffer analysis. We have an input, an output, and we have the buffered distance and the units, and these are other optional stuff and variables here. So after buffering these clip shape files, we had to convert them into rasters. So converting these shape files into raster, we used arcpy.polygon to raster conversion. So we have an input and how we're gonna, what are the units of the raster, which is a distance, and the output and the cell size. The cell size was provided here as 0.002 as an initial variable or local variable. After that, we used the times function to find the final raster. So these different rasters created were then multiplied together to obtain the final raster, and to combine all the previous conditions of having Walmarts nearby and highways near but not that near. And the final process the final step in the geoprocessing function was adding this final raster to the map. So this takes the final raster and adds it to the map. We identified the mxd function, which defines the map documents, the df function, which defines the data frame, and the make layer management function, which tells the arcpy that we're gonna input a raster, not other kind of file. Then we created the raster layer and identified the transparency. This 50 means that it's 50% transparent, and then we added this to the map and we set the map extents using df.extent.
So once we had our geoprocessing finished within the script, then we needed to write a PDF So we defined city as a global variable because we used it again and again into these different functions. And then we defined a path for the PDF, which was part of the master folder, which was a parameter that the user specifies. And then plus the Z atlas plus the city atlas.pdf. So this Z atlas is because we're saving this PDF in the same master folder, but we didn't want the atlas folder to end up being run through the loops. So we put a Z out in front of it to make sure that it went to the bottom of the list. So then we told the program to remove any existing PDFs, and if it didn't work, to send a message saying it didn't delete anything. Then you have to specify your, whatever that's called, map document, excuse me. And then our script also went through and updated those text elements that we saw in our template. So it updated the title to where to live in the city that it was currently on, and then to update the page to be a function of whichever step of the loop you were on. So then the script will export the map to a PDF, and then we'll reset all those text elements back to the original thing, which is why in our template that we showed earlier, it just looked like a title and then page because it had already been reset because of the script, and then refresh the active view on both of those so that when it gets exported to a PDF, that's what it sees. So the way that we had this code working was we set up a loop that goes from range 0 to 10 in the cities folder. And the cities folder is the same folder as where the master folder was. So the user specifies the master folder, the code says go look there and list it, find the cities folder, and that's what it is, and then it creates a list, and the city is equal to whatever step of that list we're on. So then it prints the city so that in ArcMap the user can see which city we're working on. And then it defines all these different variables as the city boundary is equal to this place, which is inside the master folder, and it's the city, the freeways is in the master folder. This is super important in our code because all the cities had a very similar naming convention inside each folder. So they had to keep the same type of folder. So they had to have the freeways folder, Walmarts, airports, hospital, otherwise the code would get lost. So then for each step of the loop, it would run the geoprocessing function that Hani talked about, and then it would run the write PDF function that I just talked about. So after all the different PDFs were created for the city, then we have the create atlas function, which is just a generalized script or function that runs after the loop is done, that goes through, finds the folder in the Z atlas, and then makes a list of all the PDF files that have that extension on the end of them, and then it appends them in its own loop. That file is the first in the list, and it goes from 0 to 10, and it just appends all those onto a master folder. So here you can see that master document that we were talking about. So we have 10 different pages of the file, and each page has its appropriate title, has an appropriate page number, and they are in alphabetical order because that's the way that the loop is set up. As we can see here, we've got our legend with our site raster, with the high values being the most desirable places to live and the low values being the lowest or the least desirable places to live. So on the map you can see that out here would be a great place to live, but in here in Austin maybe not so much. The date also updates automatically, as well as the coordinate system and the projection, as well as the scale. So that's our project. We have now our script that can be used again and again, whichever city you want to analyze. You just need to make sure that you follow our naming convention, which is explained in the help document, and that you have the right type of shapefiles so that the ArcMap can read it.